Hello, everyone. Today we will introduce Hikvision NVR for Hello, everyone. Today we will introduce Hikvision NVR for you. What's NVR? NVR means Network Video Recorder. Hikvision NVR is not just a recorder, but a powerful management system, which combines various advanced technologies, with camera management, data protection, event notification and others to make an easy-to-use, efficient and complete management system. NVR is usually a very important part in CCTV system which we usually use in security work. Today let's have a study at why NVR is important and what exactly we can get from it. These are the objectives of this course. So with this training, we hope that we can support you to better understand the main work of NVR and get a general idea about Hikvision NVR product family. And also can become familiar with the main functions and applications of NVR, and also can better understand how to deal with some common troubles. These are the main contents of this training. We divide it to be 3 chapters. The first chapter, we will introduce Hikvision NVR product family, so you can know that what kinds of NVR products are available in Hikvision. And then in chapter 2, we will introduce the main functions and applications of NVR product, so what benefits we can get from NVR. And in the last chapter, we will introduce some ideas about how to do troubleshooting when you meet some common problems during your work with NVR. Let's start from chapter 1 product family. In this chapter, first we will give a brief introduction about the working process of CCTV system, and the main role of NVR in the system. And then we will introduce Hikvision NVR product family. And then we will introduce the naming rule of Hikvision NVR. Because from the name, we can get a lot of detailed information about NVR. It can help us to better understand an NVR product and to choose a most proper one according to our requirement. First, working process. This is a very basic CCTV system. It's combined of the front end, back end and also we can add a monitor if you want to display the image. In the front end, the role of camera is to collect images, and then the image data will be transmitted to the back end. So NVR is the back-end device here. The main work of NVR is to do decoding, storage and playback. And then we can also connect a monitor to the NVR to display images. Here is the NVR product family. We divided it to 8 series. ESSD NVRs, which means NVRs with built-in SSD, Wi-Fi series, Q series, K series, I series, M series, MV Pro series and Super H series. You can focus on the series with typical features, and the update points, which we marked as yellow in this chart. K-series NVRs with AccuSense version D is newly released. It has enhanced decoding capability, up to 16ch 1080p decoding. MV Pro series NVRs are new models, compared to the M series, with intelligent functions, such as perimeter protection with self-learning, AccuSearch, facial recognition, video structuralization, and falling objects detection. Super H series is instead of old Super I series. It has higher bandwidth, improved decoding capability and larger storage space. And new models with 20/30 HDD slots has been newly released. What's new in this year, that NVR's about I series has been updated with NVR 5.0, which means brand new GUI interface according to the business applications. Here the product family of Deep in Mind devices. We have Deep in Mind AIOP and Deep in Mind M series NVRs. Deep in Mind M AIOP. It support business fragmented applications, built-in rich hotspot algorithms plus AI open platform training algorithms, people, vehicles, events, behaviors, AIOP algorithm. One device for multiple scenarios use. Deep in Mind M. It supports 4 basic intelligent functions. Each engine supports 1 intelligent algorithm, and it can support multi-channel video analysis. Then, let's know about the NVR naming rule. DS represents for Hikvision products, while IDS means Hikvision intelligent products. The second part you can meet 67, 76, 77, 96. They represent for different sizes of NVR devices. Next 2 numbers are really important for NVR model. It represents for the channel number, which can be connected to the NVR, 16 means the NVR be accessed by 16 IP cameras. N means NVR, while NX means NVR with deep learning. I means international products. Next letter represents the series of NVR. We just meet them in product family. We have Q, K, I, M and H series. The number after the series letter is HDD slot. 1 means NVR has only one HDD slot, while 2 means 2 HDD slots. And the suffix of a NVR model can tell extra functions, which the device supports. Here 16P means NVR with 16 PO interfaces. M means metal case. W represents for Wi-Fi. 4G means NVR with 4G module. R means the NVR supports redundant power supplies. When you meet the model has LCD in the suffix, which represents for our NVR with LCD monitor. S represents for intelligent perimeter protection. And the VPRO means perimeter protection with self-analysis. Okay, so we have finished chapter 1. Let's have a quick review together. In this chapter, first we gave a brief introduction about the working process of CCTV system. Do you remember what's the main work of NVR in the CCTV system? There are 3 key words, remember? Yes, decoding, storage and playback. What's the meaning of these red marked letters, numbers? IDS 7732 NCHI M4/16p. X. It is a Hikvision Deep in Mind Edge products. It supports 32 channels of IP video input, with 4 HDD slots and 16 PO ports, supports intelligent functions. Then, let's go to chapter 2. In this chapter, we will introduce the main functions and applications of NVR, which include IPC deployment, data storage and management, live view and playback, bandwidth control, non-video management and alarm and event. First of all, let's see the first part of IPC deployment. We need to know about the access capability of NVRs. Just like we said before, the NVR accesses network cameras, and this capability can be affected by factors below. Channel numbers. The number in NVR model name has shown the maximum limitation of IP channels. We cannot even add one more over the allowed channel number. Second factor, which can affect the accessing capability, is resolution. Each NVR has the limitation of resolution. It means the maximum resolution of IP cameras, which can be connected to the NVR. Third factor, incoming bandwidth. It is an important parameter of NVR. We should know that the total bandwidth taken by the cameras should not exceed the incoming bandwidth limitation of NVR. Besides, you should know that the total bandwidth means that we need to consider the bandwidth of mainstream, substream, event stream, pictures altogether. So sometimes the clients may have doubts about the NVR access capability, that according to the model name, the NVR can access 32 channels of IPC, but I only connect 16 IP cameras to the NVR, and it shows that the NVR cannot access more IP cameras. What's the reason? It may be caused by the incoming bandwidth of NVR, which means all these 16 channels have taken all the bandwidth of NVR, so the NVR has no more capability to decode other channels. Okay, we can connect the IP cameras to NVRs, but we need to know how does IP camera get powered. Here comes the PO technology. PO means power over Ethernet. It is a technology for delivering power to the devices over network cables which are used to transmit video. With the PO port, video can be transmitted up to 250 meters. With the PO technology, we can save the wiring cost, and one cable solution make maintenance more simple as well. Well, then let's move to the camera management part. To access an IP camera to NVR, what kinds of steps do we need? First, before we add the IPC to NVR, we need to active NVR in advance. You can check the picture on the right side. Here we show the NVR activation interface on new local GUI 5.0. Just remember to create a strong password and active the device. Then, next step, we can add IP cameras to NVR. The first method is plug and play. This is a very convenient method. PO cameras can be plugged into NVR PO ports for direct connection and display. But please notice that before plug and play, the camera shall be in active status, or active with the same password as NVR. And the second method is activate cameras and quick add. In the new GUI 5.0, when you go to the device access, you will find the online device list in the page. Choose the channels you need, activate or quick add them. One thing you should know that, only the cameras are located in the same network subnet with NVR, it will show in the online device list. Based on online detection for IPC, we can enter IP address, protocol, management port, username and password to add an IP camera. Besides, if there is a 4G IPC, which is connected with public network, with the fixed IP or DDNS, we can add the IPC to cameras on based of public network. And after adding IP cameras, we can start to do camera management. We can do some operations such as display settings, and we can set camera OSD to display some information on the image as you need. Except for that, we can also set the video parameters on NVR local interface, like stream type, resolution, bitrate type, frame rate, etc. And next function is IP channel import and export. How to use it? For example, you already added some IP cameras to one NVR and have done some configuration. Now you want to change to a new NVR. One way is that you can add these IP cameras to the new NVR and configure them again, right? But it will cost a lot of time, especially when there are many IP cameras. Here is one way to do it easily. We can export these IP channels as an editable Excel file from the old NVR to a USB, and then to import these information from the USB to the new NVR, which makes it fast and convenient to deploy IP cameras over NVR. Next function, virtual host. What is it and when we need it? For example, there are two LAN ports of different IP addresses on the NVR, which are isolated from each other. As you can see from here, they are in different network segments. And if you connect one IP camera to LAN 1, and connect one computer to LAN 2, so the IP camera and the PC will be in different network segments. Thus direct access can't be achieved between them, right? So if we need to access to the web page of the IP camera on this PC, what can we do? We can use virtual host function. NVR will work as the virtual host, and the direct access can be achieved between the IP camera and the PC even they are in two isolated LANs. So this is the benefit of virtual host function. Okay, these are all the contents of IPC deployment part. Next let's move to the data management part. Data security is very important in CCTV system. In Hikvision NVR, we protect data security from 3 levels: HDD level, file level and system level. Let's start with HDD security. The first technology is HDD quota. We can divide one HDD to be several quotas, and each camera can be allocated with one quota for the storage of recorded files and captured pictures. Why we need this? Because for different cameras, the required storage space is different, since required storage space relates to several factors such as camera resolution, bitrate and recording cycle. So we can divide different quotas to allocate different cameras to achieve a more organized storage management, which can also be more secure and reliable. The second technology is HDD group. In HDD group mode, we can configure different HDDs to different groups, and different cameras can be assigned to be recorded in different groups. It's a little similar to HDD quota, can also provide a more organized, more secure and reliable storage management. Then next technology is called RAID. RAID is an important storage technology that combines multiple HDDs into a logical unit. We have several RAID levels: RAID 0, RAID 1, RAID 5, RAID 6 and RAID 10, which is a combination of RAID 1 and RAID 0. And each RAID level provides a different balance among these 4 key goals: reliability, availability, capacity and performance. Each RAID level has its advantages and disadvantages and is suitable for different requirements. Let's make more study on these different RAID levels. The first one is RAID 0. For RAID 0, the minimum disk number is 2, and the advantage is that it supports a higher reading speed. Why? We can see that, if we have 2 disks in RAID 0, all data will be divided into 2 parts, A1 and A2, B1 and B2. So in this way, we can manage data in a more organized way. Thus we can enjoy a higher reading speed. And the disadvantage is that there is no redundancy because data in different disks are all different. There is no redundancy in RAID 0, so it's not reliable enough, and it doesn't allow any disk to get failed, because any failed disk will cause data loss. Therefore, RAID 0 is not suitable to be used for mission-critical type applications. And if you need redundancy, you can consider RAID 1. The minimum requirement of RAID 1 is also 2 disks. The advantage is that it has excellent redundancy. How? You see that the data in disk 1 and disk 2 are all the same. Here is one working disk and one redundancy disk. Thus RAID 1 can provide an 100% redundancy. But the disadvantage is that the disk utilization and recording speed is lower. Because half of the disks will be used as redundancy disk, not normally working disk. And because of the redundancy, the same data will need to be recorded into 2 disks, so the recording speed is also lower. And also with redundancy, we can allow one of each 2 disks with the same storage content to get failed. And please notice that the disk number of RAID 1 needs to be even numbers such as 2 or 4 or 6, half of them are working disks and half of them are redundancy disks. And next level, RAID 5, it's the most recommended one in most scenarios. Why? Let's check together. The minimum disk number of RAID 5 is 3. The advantage is that it has both good performance and good redundancy. We can see that here for A1, A2 and A3, they are very similar to what we introduced in RAID 0, right? The data can be managed in a more organized way, so it can provide a good performance. And then there is a new part called parity. Parity relates to redundancy. For example, for data package A, first we can divide it to be 3 parts to be stored in 3 disks, A1, A2 and A3. Then we need one more disk to have the parity. Then if one of these 3 disks gets failed, for example, if disk 4 gets failed and A1 data gets lost, we can calculate A1 data back with a parity. So this is how RAID 5 achieves redundancy. And compared with other RAID levels, there is no obvious disadvantage for RAID 5. And for RAID 5, as what we explained, there is one parity part, so we can allow at most one disk to get failed. One parity can only support to find one data part back. And what can we do if we feel one parity not enough? We have another option, RAID 6. Based on RAID 5, if we add one more disk to be another parity disk, we will get RAID 6. So in RAID 6, as you can see here, we have 2 parity disks. So we can allow at most 2 disks to get failed, so the reliability becomes higher. But the disk utilization will become lower. Therefore, RAID 6 can be suitable for situation where there is a high request for accuracy and integrity of data. And the last level is RAID 10. It's a combination of RAID 1 and RAID 0. So we can know that the minimum disk number should be 4. The advantage is the combination of RAID 1 and RAID 0, excellent performance together with excellent redundancy. And the disadvantage is the same as RAID 1, the disk utilization is low, only 50%. And also the same as RAID 1, we can allow one disk of each RAID 1 to get failed. Okay, so this is the introduction for all 5 RAID levels. And then the last technology of HDD security is a SATA, an interface to connect external disk. When there is an SATA device connected to NVR, you can configure a SATA for the use of record, capture or export, and you can manage the SATA in NVR. Here is a notice that for now we can only find a SATA configuration in GUI 4.0. Except the physical HDD management, we can also add networking HDD storage to NVR. If you have known about the networking storage, you may heard about the NAS and IP SAN. Hikvision NVRs with GUI 4.0 support up to 8 NAS, IPSAN, max. Capacity is 8 TB for each NAS, IPSAN. NVRs with GUI 5.0 support up to 8 NAS, IPSAN. No limit for each NAS, IPSAN. Here we show the networking HDD configuration pages of NVR 4.0 and NVR 5.0. Okay, that's all about the HDD level storage. And next level is system security. There are 2 main technologies, ANR and N+M. First, What's ANR? The full name of ANR is Auto Network Retrieval. Normally, IP camera and NVR are connected via network cable, and when the camera collects images, the data will be transmitted to the back-end NVR. But sometimes the network may break down, so the data transmission will be blocked and may cause data loss. So what can we do? We can put an SD card in the camera in advance, then when the network breaks down, the camera can start recording video in the SD card, and then after network recovers, the recorded video will retransfer back to NVR. So in this way, we can protect the data security even when the network breaks down. And please remember that SD card is necessary for ANR functions and we need to put the SD card in the camera in advance. Let's check what technologies are used for file security. The first one is cycle recording. The storage space of one HDD is limited, so what will you do if one HDD gets full? You can change to a new one, but it will cost more, right? If the data already recorded before, and it is not important, we can enable cycle recording to overwrite the HDD after it getting full, thus can save resource. And the second technology is redundant recording. In this way, NVR will save the recorded files and captured pictures not only in the working HDD but also in the redundant HDD. So it can be more reliable but the disk utilization is not high. Next technology is expired recording. If one file is not so important and it doesn't matter to lose it after some time, we can set an expired time for the file, so it will get expired automatically after reaching the configured expired time, so can also save resource. And the last one is called file lock. When there are some files which are very important and we don't want to lose them by accident, we can lock these files and these locked files won't be overwritten in cycle recording, so we can better protect them. Okay, so these are 4 technologies for file security. We have cycle recording, redundant recording, expired recording and file lock. Next technology for system security is N+M. N means the number of working NVR in the system, and M means the number of backup NVR. So how does it work? Normally IP cameras are connected to the working NVR, and data is transmitted to the working NVR. But if the network breaks down, the data transmission will get blocked. Then how can we protect the data security? We can configure one or more backup NVRs in advance. When the network breaks down, the cameras will switch to the backup NVR and continues recording, and then after network recovers, the recorded video will retransfer from the backup NVR to the working NVR. So in this way, we can protect the data security. And please notice that one backup NVR can only take over one working NVR at one time. So if there are 2 working NVRs offline, we will need 2 backup NVRs to take over their work. The limitation of both N and M is 32, so we can configure at maximum 32 working NVRs plus 32 backup NVRs in one system, which allows to design the system in a flexible way based on the requirement. Okay, so this is the part of secure data management. Let's have a quick review. We protect data security mainly from 3 dimensions: HDD, file and system. For HDD security, we mainly have 5 technologies, including HDD quota, HDD group, RAID, ASATA and networking storage. And then for file security, we mainly have cycle recording, redundant recording, expired recording and file lock technologies. And for system security, we have ANR and N+M.